Okay, these are video solutions to the Unit 4 test in the WebAssign Clarkson Math Refresher. And we're working primarily with inequalities in these virtual tools, but there are some questions that come back from other units on factoring and solving equations and working with radicals and things of that nature. Um, Question number 6 here, we've got a compound inequality, right? -1 is less than 3x plus 5, and 3x plus 5 is less than 26. So, in keeping with the concept of breaking this into equalities, I'm going to think of this as -1 equals 3x plus 5. Um, and I'm going to think of 3x plus 5 as equaling 26. So it represents two situations that are you're being obligated to. And I think individually these are pretty easy things to solve. You get -6 equals 3x, so x equals -2 is one point of concern. And then 3x equals 21, so x equals 7 is your other point of concern. And just as we did in previous examples, what you do with these is load these up to a number line in numerical order, so -2, and then the other one is 7. And then because these are pure inequalities, there's no equal to, there's no line underneath these inequalities. Those points themselves, the -2 and 7, are going to remain open, right? And then from there, if we just test numbers in the intervals like we've been showing, for instance, if we try x equals 0 in the original compound inequality, if we replace the x by a 0 and ask ourselves, is the resulting statement true or false? Okay, and so I get -1 is less than 5, and 5 is less than 26. And that's my question. And that's true. That's certainly a true statement. 5 is between -1 and 26. What that tells me is every number in this region between, strictly between, not including, uh, -2 and 7 is going to result in a true statement. It will work in the given compound inequality, so those numbers are fine. Now, if you try a number bigger than 7, like if you try a number such as, say, 8, then you'd have -1 is less than 3 times, replace the x by an 8, plus 5 is less than 26. And so -1 is less than 24 plus 5 is less than 26. Well, the first part of the inequality is true. -1 is less than 29. That part's true. But the second part, 29 being less than 26, this part fails. And so the whole inequality statement fails. Logically, you're looking at an and statement, right? Logically, we're understanding that it's an and condition. And so both parts have to work, and the first part works, right? But the second part fails, and so numbers bigger than 7 would not be included. And then likewise, you would do the same thing with a test number of -3. So -1 is less than 3 times -3 uh, plus 5. Is that less than 26? Well, that gives me -1 is less than -9 plus 5, which is less than 26. And so -1 is less than -4 is the first part of our condition, and that's false. That fails, right? That fails. -4 is less than 26. The second part's true, but you failed right here on -1 being less than -4. And as I mentioned, both parts have to be true. So the only solution are the numbers from -2 to 7. So you go to your virtual tools, and at -2 you would put a little open circle. Now that's a closed circle, so I've got to change that. It defaults as a closed circle. It needs to be an open circle. Or you could use the parenthesis. If you wanted to change it to say that symbol, you could if you're more familiar with that. And then the upper bound is 7. So I go over here to 7 and I add 7. I put the dot at 7. And that's where it's going to end, and it's not inclusive. So again, either it's the open circle or it's the parenthesis. Then you grab the draw tool and you shade the region between them, and that would be your answer. Okay, so that's question 6. Um, question 7 is similar. We've got a quadratic inequality. We've talked about the quadratic inequality before. Again, I would say don't do inequality. Treat it as if it's equal and then test intervals, particularly if you're having difficulty. The reason we do this is it sort of mocks a technique that we use in the calculus called first and second derivative tests. And so that's sort of why we're doing this way. Now, 3p squared minus p minus 4 would then equal 0 using the standard procedure of getting one side to 0. And then factoring this might be an issue. If you're having trouble factoring things, you might want to go back to Unit 1 and review factoring. It's going to be a 3p and a p. And I'm going to put a minus 4 in here and a plus 1 in here. Now, if you're having trouble factoring, get back to us. Let us know. This is a sort of a spiraled in part of it right here, solving uh, things that where you have to factor. Factoring was a Unit 1 skill, and that's something you might want to review. Now, from here, we get p plus 1 equals 0, which yields p equals minus 1, would be one number of concern. And then the other number is a little bit ugly because we got 3p minus 4 equals 0, and that's going to solve to p equals 4/3, which is a little bit bigger than 1, right? 1 and 1/3. So you would load those up on a number line, right? We'd load these up something like this, and we put them in numerical order. So the negative 1 is going to be to the left of 4/3. And the numbers themselves, because equality is allowed here, you gotta greater than equal to. So the equal to tells me these numbers are included. They work. It's a closed in bubble. Okay, those work. And then you just test intervals. Now between negative 1 and 4/3, I would probably check like x equals 0. And I'll do that check up here. Okay, so we got 3 times 0 squared. And the question we're asking is that greater than or equal to 0 plus 4? So I took my test number and I replaced the x by the test number. So I get 0 is greater than or equal to 4. And that's the question you're asking yourself. And that's what? That's a no. Numbers in there will not work. Now, if you check a number down here, a number less than negative 1, like x equals negative 2, if you were to use x equals negative 2, which is to the left of negative 1, you would get 3 times negative 2 squared. And you would be asking yourself, is that greater than or equal to negative 2 plus 4? Well, negative 2 plus 4 is 2. And 3 times negative 2 squared is 12. Because negative 2 times itself is 4 times 3 is 12. And so is 12 greater than or equal to 2? That's a yes. And so those numbers do work. And you would find if you tried a number up here, like say x equals plus 2, you would find that that also works. Okay? You would find that also works. So numbers in that region are going to work. All right? You go to your number line, and you would locate on the number line minus 1 pretty easily, right? So there's minus 1, and I want an open circle there. So I'll put that in. And then the other number that you've got to locate here, 4/3, like I said, that's 1 and 1/3. All right. So 1 and 1/3. as you look at this scale now, here's 1, here's 2. So 1 and 1/3 is in between them, right? This mark in the middle, that's going to represent 1.5, 1 and 5/10. Well, 1 and 1/3 is 1.3 repeating, right? So it's going to be a little bit less than 1 and 5/10. So I'm going to grab my virtual tool here, and I'd want to go down here somewhere. There is a tolerance built in, so if you're not right on the mark, it'll still probably take your answer, okay? And then we just grab the draw tool, and we want to shade down below -1, so it does that. And we want to shade up above 4/3, so it does that. You submit that answer, and will you get full credit? And the answer is no, because what about the bubbles themselves? The bubbles themselves got to be included, right? So I got to go back. I got to go back to my bubbles here, which means I just grab this tool again, go back here, and I can go in there and change that to a marked in, and go in here and change that to a closed in, and then submit that answer, and I'd be correct. So we're seeing a couple places where we think people are just experiencing growing pains with the virtual tools, and that's causing them maybe a little frustration, a little difficulty. But practicing with them now, that way when you get to campus in the fall, you won't experience the same difficulty. Um, the learning curve won't be so steep for you. So practicing with them now is definitely to your benefit. All right. Now, I'll get rid of this, and then we'll move on to question 8. All right. So that's out of the way. And now we'll put up 8 and 9. And question number 8 is a factoring exercise. So as you look this thing over, this is from Unit 1, 2x cubed plus 3x squared minus 8x minus 12. And you should remember, if I put an x in here, you should remember factoring by grouping. So in the first pair, if you factor out the lowest term, if you factor out the x squared, you're going to have 2x plus 3. And on the second pair, whatever that sign is on that third term, you're going to factor that sign out. So we're going to factor out a negative, and we're going to factor out a -4. And lo and behold, that's going to leave us with a plus 2x and a plus 3. Because when you divide out a -4, which is what you're doing when you're factoring, it's going to change that negative sign to a plus 2x. And that -12 divided by -4 is going to be a plus 3 right there. And then you see right here, you have a common element. And so you factor out the 2x plus 3, and that leaves you with an x squared minus 4. So that is factored, but it isn't really factored completely because x squared minus 4 is a difference of squares. And so while the key actually allowed it, I think, this really should be factored further. This x squared minus 4 term should have been factored to an x plus 2 times an x minus 2, either order there by commutativity. Any of these terms can be in any order you'd like. And you click in the answer box and enter that, and you should be fine with that. All right. Um, question number 9. So there's the answer we're looking for. That's completely factored. Right? Question 9. 3x equals, right? Get rid of the inequality if you're having trouble. 3x equals 2x squared. Well, you got a quadratic, so most likely you're going to get one side to 0, like that, right? Quadratic equations get one side to 0, okay? And then from here, I'm going to factor out the x, right? Because they both have x in common. And then I'm going to use the idea that a number times a number is resulting in a 0. So either x is 0 or 2x minus 3 is 0. Now 2x minus 3 solves to x equals 3 halves, right? So then on my number line, what I would want to be doing on my number line is I would want to locate 0 and I would want to locate 3 halves. Now, do the numbers themselves get filled in? Well, because we have equality, right? Less than equal to, those numbers get filled in. You want to use the closed in bubble, right? And then you got to test numbers in each interval. It's probably noteworthy that 3 halves is 1 1/2, 1 5/10. Okay, and so a good test number right in here would be the number 1. So you check 3 times 1, and in the original inequality, is it less than equal to 2 times 1 squared? And of course that means is 3 less than or equal to 2. And so that interval's a no. Those numbers do not work. All right. Whereas if we try a number like 2, right? Try 2 in the original inequality. 3 times 2, is it less than or equal to 2 times 2 squared? Well, 2 times 2 squared is 8, and 3 times 2 is 6. So is 6 less than or equal to 8? It sure is. So that gets shaded. Okay, that gets shaded right there. And then if you try a number less than 0, for instance, if you try -1, always be careful when you're using negative numbers. We've got 3 times -1. Is that less than equal to 2 times -1 squared? Well, 3 times -1 is -3. And is that less than or equal to what certainly is going to be a positive number, because you're squaring the negative, you're going to make it positive, right? And then multiplying by 2. So that actually ends up being a 2. Is -3 less than or equal to 2? Well, that's a yes. So those numbers are going to work, right? Those numbers right there will work. I'll be happy to take those. Shade that in. Then go to your virtual tools. Identify the points of interest, which we identified as 0 through equality, and it is a filled-in circle, which is what I want. And then 3 halves, 1 1/2. Can you agree 1 1/2 is going to be right about, say there. All right, and that should be a filled-in circle. And then you grab your draw tool. I'm going to shade down here. Grab the draw tool and shade up there, and that would be your answer. All right, so those are another inequality. Um, Next one, a little bit of interest here. A few people had some trouble here, so let's just take a peek at this number 10. And as you look at this expression and go to equality, right, x plus 4 over x squared minus 9 equals 0. Okay, well, first things first, I'm a little bit nervous here because we have a denominator with a variable in it. And anytime you have a denominator with a variable in it, you have to worry about division by 0. Now, in this case, is it clear? X cannot be 3. All right? X cannot be 3. If x is 3, that denominator zeroes out. And it's also apparent x cannot be -3. All right? You cannot have denominators go to 0. So those are going to be two numbers I'm concerned about as I work with these, right? And then the other point of this is, when is a fraction equal to 0? Well, it will be equal to 0 if the numerator is equal to 0, which gives me a number of -4 that I'm focused on. All right, so then I go to my number line not only with the points of equality, but also with those undefined points. In other words, I got to have -4 on my number line. I got to have -3 on my number line. And I got to have 3 on my number line. Okay? Now, greater than, equal to, right? Greater than, equal to. And we've been saying when it's an equal to, we shade in the bubbles, right? But the -3 and the 3 are not allowed. Those are illegal values. They're not in our domain. X cannot be -3 or 3. So even though we have the equality right here, even though we have that equality, these bubbles are going to stay open. -3 and 3 are disallowed. They are not part of the domain for this expression. And so they're excluded, even though we have an equal to situation. All right. Now, if you go and do our little test routine here, for instance, up here, a number bigger than 3, if you try 4, you're going to have 4 plus 4 in your numerator. And in the denominator, is it clear you're going to have 16 minus 9? And really, all you're worried about is that a positive number? It's got to be greater than 0. And so you've got 8 over 7. So those numbers work. Numbers bigger than 3 work. Numbers bigger than 3 will work. Okay. Now, number in between -3 and 3, pretty obviously, use 0. And so we get 0 plus 4, which is certainly positive. And we get 0 minus 9. And the question is that greater than or equal to 0? Well, that gives you -4/9. Is that greater than or equal to 0? That's a no. So numbers in that region won't work. All the way from 3 to -3, none of them are going to work. Just by testing that one number, I can tell everything about that interval. Okay? And then finally, if we use a number in here, like -3 and 5/10, okay? So we've got -3 and 5/10 plus 4. Well, that plainly is going to be positive. And -3 and 5/10, when you square it, is going to be bigger than 9. So when you subtract 9, you will end up greater than or equal to 0. In other words, my numerator is going to be 5/10, right? My numerator is going to be 5/10. -3.5 plus 4 is 5/10. The denominator, -3 and 5/10 squared, means -3 and 5/10 times itself, and that's going to be 12.25. Okay? That's going to be 12 1/4 minus 9. My point being, this number, this quotient over here, that's got to be a positive number. So it's got to be bigger than or equal to 0. Okay? So numbers in there work. Numbers from -4 to -3 work. Those are acceptable. Right? But if you get the other side of -4, if you get to -5, then we've got -5 plus 4, right? We're looking for greater than equal to 0. And the denominator is plainly 25 minus 9. So can you see that here we're going to have -1, and it's going to be over 16. Is that greater than or equal to 0? That's a no. So numbers down there don't work. Numbers below -4 don't work. All right. You go to your number line tools. Okay. Go to your number line tools and identify the numbers you're interested in, which would be -4. And that's okay just the way it is, shaded in like that. -3, but -3, I'm going to open up. That's got to be an open circle. It missed it. It's got to be an open circle. It doesn't want to make it an open circle. There we go. And then 3, right, which is right here. There's tolerance built in, so if you miss it by a little bit, that's usually okay. Notice, again, the -3 and the 3 don't get shaded in, but the 4 did. Now I just have to use my draw tool and pick the intervals I want. I want the interval from -4 to -3, and I want everything above 3. There's your solution. All right. So that question, we saw quite a few errors on that question. Make sure you run through this again if you need to. We treat it as if it's equality. We identify any numbers where it's equal to 0, the only number being -4. And we also had to worry about the denominator equaling 0. So that generated these numbers, which also had to be accounted for in our number line. And then just as we've done with the others, you test intervals on the original inequality to see if the statement ends up true or not. If it ends up true, you shade it. If it's not true, you don't shade it. Okay, so that's our questions 6 through 10. And if you have any more questions on these, just let us know, and we'll try to help you out.